Everyone. Everyone. And let me check if everything looks good to me. Okay. Hello. 1 second. Let me configure if everything we are live on YouTube and we are live on LinkedIn also. So I'm checking things looks good. Yeah. Yes. Okay. 1 more minute. Good. Okay. Yeah. 12 people have joined on YouTube. How many people are there on LinkedIn? Let's see how many people have joined on LinkedIn. LinkedIn, 5 people have joined. Okay. Good evening, everyone. Welcome back again to Analytics with Anand. So today's, after a long time, I have come live here on YouTube to discuss all the important case studies which you keep seeing coming up in the interview. And also, this will be really helpful for you down the line if you work in any data analytics position or business analytics position, or even for the data and engineering business role. So today, I have invited, soon he'll be joining, Michael from Nigeria. I have invited him. He basically belongs from agriculture background, and how he has done the transition into the data analytics, and he's working for a very big company as a data analyst. He's a Power BI certified, Tableau certified, and also a certified data analyst. Soon he'll be joining with us, and we'll talk about his journey, and then slowly we'll progress about the case studies which we're going to do it in the Snowflake. Those who are new, those who have joined this for the very first time at Analytics with Anand, everything which you see here, it's completely live. There's no pre-recorded videos, and it won't come ever here. Right? All the recordings, all the everything is coming live here. I come here along with other folks and we teach online here, right? So you see things in reality, not like another YouTube channel where they post recorded videos. So I don't follow that approach. So everything you see here is the live. Now for the today's session, for the case studies, in the description, kindly go through the description and read all the details, all your GitHub files, repository, datasets, everything I have uploaded over there. So anytime, any doubt, just observe what has been discussed in this class. So if you're a newbie to the data analytics, if you are coming from a non-tech background, and if you want to see how things works in the IT industry from SQL point of view, from case study point of view, this is the right platform where you have landed yourself, and this is the right live session which you will be a part of this. Right? So stay tuned. I think Michael will be joining us soon, and then we can take care from there. Anyone has any doubt, feel free to explore the chat section. Do subscribe to the channel if you have not done so, and do enroll in the ongoing job guarantee program if you have not enrolled. So if you want to establish your career, guys, in the current 2024, in this century, 21st century. Data analytics is the skills. Data analytics, you should aim for, be it from any background. I'll make sure you land a successful career in this if you are ready to devote your 8 months of journey with me, right? So this is the only career currently, be it from any background. If you want to switch into the IT industry, there's no other best career rather than data analytics. I'm telling you straight away, you be it from any career background, irrespective of your background, it doesn't matter. All I want, the dedication, the passion, the consistency should be there in you, right? In order to uh, enroll yourself in this job guarantee program, in order to do the transition in the data analytics segment, right? So if you have anyone has any doubt, feel free to explore the chat section. You can post it in the comment, right? And I'll be happy to help you from there, right? Still, if you have not decided if you want to do the transition in the data analytics, you can always enroll in the ongoing job guarantee program. Go to analytics.anand, check out the app, everything details, you will get it then and there, right? Okay, yeah, it's a very inspirational journey. So I'm sharing my screen, and I'll show you how he has done a transition, all those things. And soon he'll be joining and he'll be talking himself, right? Let me see. Even I was amazed how he's doing extremely well, coming from straight from the agriculture background, and then how the journey has been so transformative for him. So here you go. So this is the Michael profile I'm sharing. This is the Michael profile. He's a BI analyst, BI developer. He's a Tableau featured author for 2023, and his portfolio looks amazing, right? I was just having a glance of its portfolio, Tableau, GitHub, resume, CV. See how nicely he has created it, right? So you should be having definitely a portfolio which you can showcase it to the real world, right? Tableau, you see so many tremendous things he has done in the Tableau. Now, those who are a part of job guarantee program or those who will be enrolling, you have a Tableau full-fledged course which is coming down the line probably in the month of January, and Michael will be taking care of your complete Tableau session. Previously, session Jay has taken. This time, I want Michael to take it, and then we'll have a full-fledged Tableau session also from Michael, right? Learning from a completely non-tech background to a technical background, you will see all those things from the grassroots level, which any person has learned from the beginning. Okay, so this is the Michael profile, which I was showcasing it to you. You can connect with him. He keeps on posting all the interesting stuffs. Link and everything, I have given it in the description. You can find it then and there. So he works as a senior data analyst and Atos. Atos is a really, really good company, by the way, I would say. Atos is a really, really good company. Prior to this, he was working as MTN as a business data analyst. And then prior to work, he was working as a product analysis and data analyst. So he started, you see, as a human resource assistant at an agro traders. So coming back to his education, he has a master's degree in data science from Rome Business School, Nigeria, and bachelor in agriculture, which I was talking about. He has a bachelor in agriculture, guys. So he will be a real role model for you all. So data analytics coming from an agriculture background and doing a master's in data science, it's a very great thing. So if anyone, right, if anyone is coming up to you and saying, okay, you are from a non-tech background, you cannot land a successful career in the data analytics. No, don't go with that. Believe in you. Talk to me. Don't go with that such negative comment, right? Have a trust on you. Have a trust on the process. It is a time-taking process. It's not like that within 1 day or 2 days, you will become a data analyst. It's a time-taking process. These things takes time. Okay? These things takes time, right? So these things takes time. So take time. 8 months is the journey. After this course, your data analyst, business analyst, data engineer, all this full-fledged career will be open for you. Doors will be open for you, right? And it's a strict guideline to everyone. Those who are a Power BI developer, do not spend your career in Power BI after 3 years. After 3 years, you should be choosing your data engineering. I see many folks are stuck in the Power BI role for 2 to 3 years. 2 years is the ideal time. 2.5 years is the ideal time. After that, start looking for the data engineering role. You should be first the data analyst, work for the 2-3 years, understand the data, understand the logic, build some good dashboards, then move slowly to the data engineering, understand the pipeline, then you should move into the data science domain, right? If you are well enough, you are smart enough, go ahead, move to data science. Nobody is stopping you, right? Just understand your caliber, your potential, and based on that, you decide your career path. And if you're very confused, feel free to call me. You have my number, you have my email ID, and you have my everything. Michael has joined, I think, right? Okay. So anywhere, anytime you are stuck in your career, do reach out to me. Anytime, feel free to talk to me, right? Okay. Hi, Michael. Can you turn on the camera, please? Let's see.
Hi, Anand. I missed what you said.
Hello.
Yeah, I can hear you,
Can't hear
Anand.
you.
Here, I'm right here. Can I turn on my camera?
Just understand your caliber, your potential, and based on that, you decide your career path. And Michael, I'm not able to hear you.
Can I turn my camera on? Can you hear me right now? Hi, Anand. Can you hear me?
Uh,
Can you hear me? Can you hear me? I'm speaking.
One
Can you hear
second,
me now? I'm
Michael,
speaking.
you there? I can't hear you.
I am here. I am speaking. Can you hear me? I don't know what's happening.
Something wrong with my voice. One second.
Okay.
Quickly, I'll check. Oh, I was on mute from here side. Oh, sorry.
Okay.
One second.
Okay. Great.
Sorry for
How are you
that.
this evening? It's quite late in India.
Settings. I think something wrong with my setting. Check my audio device. 1 minute. Yeah, I can hear you. I can hear you. Something wrong was with my mic, I think.
Okay,
Yeah.
great. Very well right now. Can you hear me well now?
Yeah, I can hear you loud and clear.
All right, great.
Let me increase the volume. Yeah, I'm good. Michael, go ahead. Michael, go ahead and introduce yourself. Yeah.
Okay, I mean, I'm really excited to be here. So
Right.
yeah, my name is Michael. I don't know. I'm a business intelligence analyst with over 4 years of experience. And my experience actually spans across different industries, I mean, marketing, sales, retail, telecommunication, and I'm currently in IT. And I love what I do, and I love to, teach what I do. I mean, I love to impact into people what I know how to do best, which is I love working with data, and I mean, it's something I do every day. Right. I love SQL. I love working with SQL. And I mean, some time ago, I picked up Snowflakes, and oh, it's really amazing. Before now, I've been working with workbenches on premise, and picking up Snowflakes. It's really such an amazing thing. It's always very, very good to work in cloud. It's
Great to
always
know that.
very
So tell me before we go to the case studies, which is the agenda for the today's session, how did you transition from the agriculture to the data analytics? What made you think in that line? Okay, no, agriculture is not the domain. Although I have done my bachelor, I see you have a master degree in data science. I was surprised. Before I was not knowing when we spoke. So when I was exploring the LinkedIn profile, when I was showcasing it to them, then I realized, oh, this guy has done masters also. So what made you transition into the data analytics? Because there are many folks who will be watching you live. Already they are watching from India and across the world. So they will be keen. They don't come from a technical background. They don't know ABCD of SQL, what is Tableau, what is Power BI. So how they should be able to cope up with all the negative comments that if you are a non-technical guy, you cannot do this. No one will allow you. Right. So how did you face such hardship and challenges? Yeah.
Okay, so for me, I mean, for agriculture, I love agriculture, and that was the reason why I started with agriculture. But I studied agricultural economics, so that's like using economic principles to solve agricultural problems. And while you are in economics, you do a lot of analysis as well. I mean, analytics applies in everything you do. You
Okay.
could be sleeping and you're not sleeping well for some time, and you really want to understand why you're not sleeping well. You want to take some data, you want to fall back to some data you have, and you understand. So from my thesis, from my final year project, I started falling in love with analytics. I know taking data, working with data, and all of that stuff. Data is very, very interesting. And that was where I actually picked up the interest. And from there, it's been smooth sail. I wouldn't really say a smooth sail. I mean, it was quite difficult starting from me
Yes.
because there were
Yeah.
a lot of challenges. Yeah, there were a lot of orders to cross, and I would see a lot of people write SQL queries, write Python queries, write Python scripts, develop very, very interesting reports. And
Correct.
ask myself if I'm ever going to do all those things. But one thing that is very important is facing your fears. If you do
Exactly.
not, then you're not really going to get there. Right. So just start and keep pushing yourself and you're gonna get there.
Okay.
And
So
I'm very sure they
initially,
are, yeah,
so
yeah, I'm very sure they
initially,
are. Oh, of course,
yeah.
you can. Anand, you can speak on.
Yeah. So whenever, so the first interview which you appeared, were you able to crack that, or how was the hardship and challenges when it comes to appearing for an interview? Because see, if 10 candidates are there and they are coming from the technical background, so these non-tech folks has a phobia or they fear in the mind. Okay, 10 guys are already there. 10 persons are already there from technical. I'm thinking I'm a Michael. Okay, I'm from agriculture background, so they won't hire me. So those thoughts, did it clinch into your brain? I'm more interested to know that.
Yeah, so when I started, the thoughts were always there because I wasn't from a tech background, I was from a non-tech background. And I always think, I mean, there's some people that actually knows this thing more than I do, right? But then I didn't crack my first interview. I didn't crack
Okay.
my second interview. I did a
Yeah.
whole lot of interviews. But then there are a whole lot of things I know now I wish I knew back then, right? If I knew things I know right now back then, I would actually have done better at my interviews, right?
Exactly.
So
Even
one thing
I
is
say
just
the
like,
same thing. Whatever I have learned now, if I would have learned those days, because those days YouTube were not there, not much popular, all these courses and Snowflake were not there. So I studied from the textbook by underlying how does group by works, how does where works. Now you have a resources. Now it's very easy for you to learn. Yeah.
that's right. So right now, I mean, there's all lots of resources out there. You go to YouTube. YouTube is a free resource center. You can get on YouTube, just search for anything, and in a split millisecond, you get whatever you want. So it's quite easier right now. For
Yeah.
me, it's a lot tough because I mean, but yeah, I got there, and I mean, it's exciting, and there are a whole lot of people like you, Anand, that I mean, you really want to, make the people, especially people from the non-technical backgrounds, and I
Yeah.
really appreciate what you do, Anand.
Thank you so much. So before we go to the case study, last question I have: what is the piece of advice you want to give to the folks who those who wants to do the transition into the data analytics? Any piece of advice from your experience which you would like to share? Yeah.
All right, the first advice would be start now. Start right now. Right now is the best time, right? I know sometimes you want to procrastinate and say, oh, I don't think it's right now is the right time to start. Or you have a job and you're thinking your job is coming your way. Just start right now. Right now is the right time to start. Dedicate some time. It doesn't matter if you have just 30 minutes of your day, you can
Exactly.
dedicate to studying, to learning. I mean, you're going to, even if it's 5 minutes, you learn a lot in 5 minutes than not learning at all, right? The small pushes that you make are actually very, very critical, right? So start right now and, make use of the resources available. There are a whole lot of free resources available. And I mean, you should also pay for some quality. I mean, if it's necessary, if you have to, but it's worth it. Honestly, I must tell you, it's worth it.
Yeah, now the market I see is flooded with all these data analytics, data science or courses, and people are really confused whom to trust, whom not to trust. So you have to choose very, very, efficiently, which is the right course which has been designed for you. Many people are not aware of what are the tech stack. Like I was interviewing few candidates, like they were like 3 to 4 years of experience, but they don't know what is Snowflake. I was like, what? You don't know what Snowflake is? Then how do you how you will work with Power BI? How do you work with Tableau? Where do you write this code? Now the days have gone where people used to write in the MySQL workbench. No, none of the companies now uses it. Everyone has moved towards the cloud. So if you don't upskill yourself in the current market, you can't survive. Yeah. Every day technology is changing, Michael. You see, some and other tool comes into the market, right? So that's how even I advise people. Always keep updated yourself. Devote some 30 minutes of time, as you said. That's very, very required. Even for us, it's not for them. Even for us, every day we even have to learn.
Yeah,
Otherwise,
I
we
still
can't
do a lot
survive
of
in the
learning.
industry. Yeah, lots of
I,
learning is there.
I still do a lot of learning right now. I do that all the time.
Exactly.
Right,
Exactly. Yeah, Michael, over to you. That you can share your screen and then we can start the case studies. Right.
right, great. I'm gonna start right now.
I'll turn off my camera. I'll go on mute now. The floor is completely yours. You take the lead from
Okay.
here. I'll come at the last. Yeah.
Okay, so we're gonna be working with two different databases. Give me a moment to share my
Yeah.
screen right now.
I might interrupt you sometime in between if I see any questions in the chat. That will be taken care at the end. Once you finish the case studies, if anyone has any doubt, let's keep 10-15 minutes at the end if anyone has any doubt, right?
Oh, that's okay. That's okay.
Okay. So guys, if you have any doubt, just observe what Michael is doing, understand the case studies, and any doubt, feel free to post it in the chat. Yeah.
All right, can you see my screen, please?
I can see it's very small. I think, Michael, you have to increase the, I think, zoom a bit.
Okay, I will do that. How about right now?
Yeah, looks good. Yeah, looks good to me. Yeah, looks good to me.
Okay. All right,
Yeah.
so I have few questions. I have few business questions right here. And like I mentioned, we'll be working across two different databases, which I've actually carefully selected. One is an employee database, and the other one is a credit and collections database. So we're going to start with the employee database. And the way the progression is going to be from the easy queries to the more complex queries, right? So without wasting time, let me introduce you to the first database, which is the employees database. Right here, Anand, I would love to share my GitHub if this is necessary right now. So, how do you think we go about it? Just want to show how to load the data and
Yeah,
whatnot.
I can show them. Yeah. You can load the data. You can do. Take your call. Yeah, it's fine.
Okay, great. So, before this class, I actually already I created my database and I loaded the data to the database, and I can quickly do a demo of that you're using Snowflake for the first time. So I mean, all you need to do is create a database with the create database, working with an employee database, and you can use the employee database. But since I already have an employee database, I can just use an employee to create my database. And the result is going to come out here, which says database employees to created. I mean, this is just a simple query with the database. And after that, you can, use the use database name, the use employees, which is the database I've just created, to tell Snowflake that you want to use this particular database. But I already have an employee database right here. After the database has been created, if I go to my GitHub right here, I closed that. I go to my GitHub right here, I actually have, which Anand is going to be sharing, I actually have it in a different branch, the master branch, where I have some queries written, queries to create the database and to create the tables in the database. It's in the HR. If you go to tables to load, all right, so here with database and table creation, if you open this particular one, this is the script, actually run to create all of the tables I have inside the database. So right here, this is the employee database, which I already created. And if you come to public, you would see the tables I created under here. So I have about 6 tables right here, which were created with the same code, with the same script I'd written right here. The fields in the different tables and constraints that comes along with all of the fields. All right. And that is it about that. And then to insert the tables. So also inside the GitHub, I have a folder that contains the different tables that inside the database and CSV. All you need to do is once your tables are created inside your database, you just come here where you have the 3 icons, select icons. You see the load table. Once you click on the load table, you can easily select where you have your table on your computer, right? You can select, you can drag into here, and then you can follow the instruction that comes. Very, very easy to do. And Anand already has a whole lot of resources on starting with snowflakes. I believe you can always revert to that if you need some more information. So with that being said, I'm going to just step right in right now. All right. I'm going to take this off the screen and we are going to start with our question. Yeah, we have an employee database. When you're starting with SQL, when you want to write your SQL queries, you just don't go straight to writing your select statements and listing whatever you want to write. The first thing you want to do is actually understand your data sets, right? You want to understand the database, you want to understand how it's structured and all of that, right? I have more knowledge about this because, of course, I actually brought this here. and I'm going to give you a little description of how all of these tables work, right? So this is an HR database, contains employees information, employee data. We have a department, which is a list of all departments. If I click this, I can preview. I'm zooming this in, so a whole lot is cut off from the screen. All right, so once I click this, you can see a preview of the different fields I have inside this data set. So I have the department number and I have the department name. If I click this, I have employee number, I have the department number, when the employee started working, there's a from date, and when the employee started working. If I'm going to explain this, different employees could start working right now. So it's a contract based. When they start working, employee number 1 could start working in department 2, right? Starts working today and stops working tomorrow. The 2 dates end. You could start another contract after tomorrow. That's another from date, another contract, right? And then we have department employee, department manager, pardon me. Department manager contains the names of the managers in all of the departments. All right. So right here you can see employee number, because the manager is also an employee. Employee number, the department number, which department the manager leads. From date, that's the tenure when the manager's tenure started, and the 2 dates when the tenure ended. And also we have employees, right? So the employees, including the managers and the non-managing employees are all employees right here. And you can see all the columns under employees. We have, right, we have what's happening. Okay, so if I should preview this, not sure why this is not loading up, all right? So, the employees, yeah, sorry. Right here, we have the employee number. It's just information about the employee, the best name, it's the first name, the last name, the gender of the employee. And the salary also contains the salary of the employee, as you can see here, employee number, the salary of the employee. The from date and start date is also pointing to when the contract started and when the contract ended. Once there's another from date, that means a new contract has started and the employee could be paid a different salary. And then the title, as it sounds, that's the title of the employee. All right, with that being known, we can now go straight to answering our questions. So the first question I have here, I need to be able to read this well. Okay, so the first question I have is you writing a query that identify the most recent salary of each employee with their title. So for each employee with an existing contract, find the most recent salary and the associated title. I mean, this looks very straightforward. This looks very straightforward. So like I said, we're going to be starting with some less complex queries and going to the top queries. All right. So what we need here, we need a few, I mean, the first thing is understanding the question, the solved, or the what's it called? The question to be solved, right? So right here, we need to understand each of the fields that we need to actually produce. So the first field is we need to identify the most salaries, the recent salary. So we need to we will need the employee number. We will need the employee salary. Of course, we need to get the recent salary. We need the last contract, all right? And then we are going to need the title from what we can see here. So with that being known, we can now start looking at how to actually construct a query. All right. So right here, we are going to need a CTE, which is a common table expression. The major reason for using the CTE because we need to actually create a temporal table which we can use later on in our query. And I'll tell you the reason why we are doing that in a minute. So, pardon me. Right. So we can start writing our query right here. We're going to start by finding the recent salary of the employees, because of course, as you can see, identify the most recent salary of of the employees. We want to write a CTE that actually fetches the recent salary of the employee, and we can start with the with clause, which is trying to write a CTE. We can start with written salary of the employees, and this is the structure we use as, right? Okay, so like I mentioned, right here, the first thing we want to understand, we want to see the recent salaries of the employees. So we can start with our select statement. Select, and the first one we want to find the employee number. We probably don't need the employee name in this regard. We want to find the most recent salary, so we need a salary. We need a from date. A from date is the date the contract expired. We can write our from date. We can use that as last contract. The last contract actually started, the from date. We need a roll number. So the roll number is to help us actually identify the different salaries, right? Because they're different from, so we want to actually understand, we want to see the different contracts, right? Because we need the most recent contract. So we're going to use a roll number. Basically, what a roll number is doing is, a roll number is a window function, which is actually identifying the different roles depending on the partitioning, all right? So this is going to make sense in a minute for those that actually do not know what roll number is doing. So this is, we're using a roll number over, and then we are going to write how we want to partition this. So we're going to use a partition by, we are partitioning by employee because we want to see the employee. We want to partition our particular table by employees and then see the different, the different contracts the employees have had. All right, so we can partition by employee number, which we already have here, and order. We want to order by the from date, which is the last contract, right? Like I mentioned before, the contract starts from the from and ends at the to date, all right? So we are looking at when the contract started, so the from date, and then we want to order this in descending, all right? We can give this a flag, we can give it a roll number. Great. We're taking all this from salaries. We're taking all this from salaries. That is the table, of course. And then our where clause, we want to do a filter that says where to date is actually greater than current date. Okay, so the major reason we are doing dates greater than current date because we are looking for these that still have existing contracts. You can see here. Okay, so we are identifying the recent salary of the employees that still have a contract. All right, there's a current function that actually fetches the current date we are in today. All right, so we are only looking at employees that still has a contract. All right, great. These are CTE. Our CTE is complete, and then can proceed to writing our final query. So in case you just want to see what the CTE is saying, you can highlight and run it. Roll number. Okay, so the problem here, over. Let's see, let's go and write in our CTEs. So we can write our final select query. Selecting, we want to select an employee number, like I mentioned. We want to select salary, right? Because we want to see the last salary. We want to select the last contract, right? We want to select the last contract here. That's we want to select the title as well, which is one of the things we need to actually come up with. And from where? From our CT, which is recent salary. All right. So since some of the fields we need in our final query actually also cut across all the tables, we are going to need a join. All right. So since we're needing a join, we actually need to give our table an alias to make it easy. I mean, you can also use the full name, but for this sake, want to use an alias. So since we're getting a title, from a different table, right? We don't have the title inside the salaries. We're getting a title from the title table. So we're going to need the title, and we're going to alias a title on. We can use the joining clause. What clause do you want to join them? the title table has a particular field which is common to the salaries table, which is where we got all the recent salaries, which is where we created our CTE. You can see we're joining on the RS, which is the recent salaries, employee number, all right, course, to the T, which is our titles employee number. And yeah, we can use a where, because we are trying to find the employee, the most recent salary. If you remember, we used a row number here, which actually identifies first salary to the last salary, and it is sorted in descending order. It is ordered in descending order. Right here, we only need the row number that is number one. So right here, we use number one, and then we can go ahead to run our query and see. Okay, so we have a problem here. Okay, so the problem right here is because right here, I didn't use a comma to separate the field. So this is a field, this is another field, all right? So that is the problem. That is the reason we have that problem. So we can run again and see from date, unexpected from order by, okay? All right, so these are some common problems. So let's run that again. And then salaries. Salary does not exist. Okay. Where do we have that employee action by from salaries? Okay, so we are going to have to actually look at our table, see where the problem is from. It says it doesn't understand where the salary, so I can go to salaries and look at fields in salary. So it's salary, and you have salary exists. Where's that? Where's that? Okay, this is how we work. We can run those first and see. Okay, so it's from here. This, what is happening? Okay, so what we're gonna do, let's give the access to our tables. Probably don't need that. Then salary. Where did we use salary? Another authorize. Employee number, we selecting salary from date, pattern by from salary. Now we've used an object name. I think you can as well look at this and see which employee number salary. Okay, it does not exist. Salaries, where's that? Okay, so we can say select all from salaries and see salaries. Check to see if the name of our table is correct. There's a problem with the name of our table. What is that? Those are the tables. Let me see, show table. Query. Am I using, let's see, use employees, use database. Okay, so that could be because of not selected our database. Let's run this again. Okay, so that is the reason. Right now we can now give we can give access to our tables. This is RS. RS, where else? Row number. And do that again. Produce no result. What is happening? Okay, so what is happening right now is the salary table actually is truncated, right? It's truncated. It doesn't have a lot of, because while I was trying to upload the table to GitHub, it was too heavy, so I had to truncate some columns. So this is the reason. But you can see that right here, the result of the query is right here, but some of the fields, the records are actually cut out, which is the reason we're actually having here, which is a problem we are having right here.
Michael, from date should be less than the current date, I believe. How can it be the greater than? Line number 13.
Where?
Line number 13, 13, 1, 3.
Okay, line number 3.
It has
Yeah,
to be
the
less
from
than.
the date should be
How
that should
can
be
be current date is today's date? So how can the
yeah,
from date
that's
should
where the
be?
problem came from. That's where the problem came. It should be the to date. It should be the dates the contract actually ended.
That's what I
Yeah,
said.
it should be it should be the dates the
Now it
contract
came.
actually.
Now it
Yeah,
came.
so it's a problem with I mean the different fields that I was using the fields. All right, so it should be today. So right here we have the employee numbers, we have the salaries, we have the last contract of the employee, and the title after the last contract of the employee, which is what the query actually wanted us to find out. All right, so this was a problem. The first problem, I couldn't run, or Snowflake wasn't recognizing my tables because I have not used employee. So when you create a database, before you use your database, you need to select your database. And the way you select your database is to use employees. If you're using it, which I did right here. And that was the way Snowflake was actually able to know that I am using the employees database. All right, which is great. All right, thank you very much, Anand. All right, so we can go
No
to
worries.
so we can go to the second question. So the second question is looking at
Can you uncomment that line number 18, where clause which you have uncomment and run once?
Yeah, that's right.
Yeah, let's see what all details we get it.
So
yeah.
So right. So these are the different employees, and in the last contract, after the last title they had, last salary they had on the day of their last contract, or on the year of their last contract, which is what we have right here. All right, great. And the second question, we have 3 questions under the employee database. So the second question is for each department, list each department's longest serving current manager. All right, so what exactly we're doing is we are finding the current manager with the longest tenure for each department. All right, so for each department, which manager has the longest serving tenure? And we only want to include managers who still have active managing, who are still managing department, I mean, who still has contract, all right, who are still in their tenure. All right, so the fields we actually need here is from what we can see here, we need the department name, the manager name, all right, the manager, the department the manager is managing. We also need the tenure length, all right, how long the manager has been serving, right? So these are things we actually need to, make this query work, right? And then we can start with a select, right? This looks more like a straight-up one to work on. We can start, like I mentioned, we need a department name. We need a department name. We will need the name of the manager. Yeah, we need the name of the manager. So the way the database is actually structured, the manager has a first name and has a last name. So we're going to have to concat the names in order to get the manager name. All right. So we're going to use the concat function. We're going to use the concat function. Snowflake makes it easy to use IntelliSense. All right. You can enter your first name of the employee, right? And this is how you use a concat. Then you can use your quotations. All right. So another thing is Snowflake only recognize the single quotation, no double quotations, right? Then you can enter your last name. We can call this as the manager name. We can call this the manager name, comma. What else do we need? We need to know when the manager start working, the from date. All right. We will need the dates the contract is supposed to end, which is the due date. And another thing we need is, now we're going to look at the difference between the from date and the to date. right? We can use a date diff because remember we're looking at the longest tenure of the serving manager. We can use a date diff here. Use a date diff function. Basically, the date is looking at the difference between 2 dates. And how it works is you need to firstly enter the type of date. If it's days or if it's years, if it's months, you need to enter it here and then enter the 2 dates you're looking at, right? So the 2 dates we're looking at is we're looking at the from date and the to dates, right? You can enter the from date and then the to dates. The 2 dates, we are only concerned about managers that still have contracts, right? So we can look at we can use a case statement here and use it to narrow down what we actually have back, right? What we get back, because if you remember, we are looking at contract managers that still have contracts. So we can use a statement that says when 2 dates, which is when the contract expires, when 2 dates is still greater than the current date, is greater than the current date, right? Then the current date here, and instead of giving us the 2 dates, just give us the current date, right? And always remember to end your case statement end, right? And then we can use our tenure length. So basically what is happening here is we want to remove the 2 dates from the from dates. The from date is when the contract started and the to date is when the contract ended, right? But we are only interested in managers that still, have an active contract. And that is the reason why we are not looking at 2 dates that are less than the current date, because the current date means if it's less than the current dates, it means that the manager's contract has expired, right? So if it's less than the current dates, if the 2 dates is greater than the current date, give us a contract, a current date rather. Great. What field do we need again? I think this is all about the field we need, so we don't need a comma here. We are getting this from the employees table. Okay, I love to vary my code. Well, so the employees table. We needed some join because many of these are not coming from the table, from the same table, like the from this and on the employees table. So we're going to have to use some joins. We're going to have to use join right here. And we are using the department manager table is where we are getting the from date and the to dates, because we are looking at the from dates when the contract started and the to dates when the contract ended. So we're using the department manager. So right here, we're using department manager. How is that spelled? Yeah, this is it. Thanks for Snowflake's intelligence. And we can alias this DM, right? And our join clause is going to be employee number of the employees table and the employee number of our department manager. So the e.employee number equals em.employee number. All right, so this is great. And then another table we're going to have to join department table, because right here we have the department name. I did a mistake here. Right here we have a department name, and the department name is neither on the employees table or department manager's table. So we are going to have to, do another join, this time to the department. And we can here's D on. We are joining on department number equals to department manager department number. So we can do the DM dot department number equals D dot department number. All right. So I think these are all the tables we need. I mean, we have all we want. We still have to alias the table. All right. And then our where clauses, we're looking for when the to date is greater than the current date, right? Can use our where clause here that says where to date is greater than the current date. Remember, we are only interested in managers that have a contract, right? It's greater than the current date, right? And then what else? Only include managers. All right, so I think we are good. So since we are looking at the longer serving managers, we can decide to limit the size of our output. Remember, you're when you're working and you're working in production, you want to try as much as possible to save. your company some cost. You don't, you just, for every query you run, there's a cost attached to it. So since we're interested in the top managers, top 7 managers, we can just use the limit to 5. The limits actually limit the number of rows that are displayed. So we can run this. Okay, last name. Let's see. The last name, where do we have? We should have an underscore here. Okay, and run that again. Okay, so right here we have the top 5 serving managers. We have the departments they are serving and how long they've been serving. You can see, right? This is a report. I mean, this looks unpresentable somehow because we are interested in the top 5, and you can see the tenure length. They're scattered. So how about we order this by the tenure length, right? How about we order this by tenure length in descending order? Back here. Okay. So we can use our order clause, order by the tenure length. And then we can make it descending. Okay. Tenure length descending. All right, cool. We want to sort this in, yeah, so from the highest to the lowest. All right. So now we have what we want here, which is great. Now we can move on to next question. Right, the next question is looking at we want to determine the average time spent in each department for the current employees. So how we are breaking down this, we are calculating the average time in years each employee has spent in the department, and report the results to the department. I mean, this is actually very straightforward. What we're looking at here, we're looking at the department name, which shows the department the employee worked, the employee's name, and the average years the employee has spent in the department. This looks more straightforward, or the most straightforward, I'd say. So we can start with a select. Right there, we can start with our select. And what are we selecting? We are selecting department name, employee. We can start with employee number, or we can start with department name. We can start with department name. On how important is order, department employee number. We need the employee name. We need the concat here on. We can still do that to make you see how that was done again. So concat, we want to concat the first and the last name. So the first name comes first name. Then we can use the space, because we need a space between the first and the last name, and then the last name can come on. All right, we can call this again the full name. All right, great. What else do we need? We need we now need the average year spent at the department. The average year is going to be the year the contract started, and the current date, right? Like we did up there. So we can now say we need a date Steve, right? So we need it in years, right? We need year of the from date, and then we are going to do a case when, just like we did here. We just want to do a case when this is greater than the current date. That is what we are interested in. We are interested in employees that still have contracts, right? We can say two dates, year, so case when two dates is greater than the current date. Why am I typing like that? All right, the current date, and we need you to give us the current date, because that shows that you still have a contract there, right? Else, if it's not greater than the if it still has a contract, else due date, then we can, and always remember to end with an end. What can we name this? Since we're looking at the, if we can look at the contract length, we can call this contract length. Right. What else do we need? Now we have our contract length, but we need to find the average contract length. So what happens is, if you do this, if you use a from, we are getting this from the department. Sorry, getting this from the department. So since all these are not from the department, we have a full name. The department table doesn't have the full name. I'm saying this because I know how the table is actually structured. I know the department doesn't have the full name. We know we are going to do some join. When you're doing a join, it's always very good to actually use your aliases. We can join. We're joining on department employee, because department employee and the department have a common field it can be joined on. Department emp. The department emp. This is the DE. Okay, that is the alias. And what are we joining it on? We're joining on D equals department number equals the department number. All right, this looks good. And what else are we doing? We're doing another join, because right here we have the full name. The table that has the full name is still not here, so we still need to join on the table that has full name, which is the employee table. All right. Now the employee table, we are joining now on employee table because the employee table has a common field with the employee department employee. We can join on the employee, and we can employees. I think that has a head. Yeah, that's correct. And then which is E, and we can join on E, so employee number, equals the D as employee number. Okay, so I think we made should be D, not E. That should be D dot, not E. All right, that represents the department. All right. So we have this. And what else do we need to do? The query says, okay, calculate the average. All right. So we can run our query and see what we have here. Okay, employee number is ambiguous. All right. So it's saying employee number is ambiguous because employee number actually comes from different tables. There's employee number on the department employee table, and there's employee number on employees table. So right now we need to actually identify which of the employee numbers we need. All right. We can use our alias to represent where we want the table to come from and where we want the field to come from, and which of the tables we want the field to come from. All right. So we can go ahead and run our ANC. All right, so we have a query right here. This is the contract length, right, for each of the department. But it's talking about the average contract length. The average. Right here, we have a div that actually, has drawn the difference between the number of years an employee has spent in the department. But right now, I want to know the average number of years the employees have spent in the department. So right here, we might have to use the average, and using an average actually comes with where am I doing that? Oh my god. All right, sorry, I might have to take that out. Now this is happening because my screen is so zoomed out right now. All right, so I'm taking that out. All right, so this is the query we're writing. So I'm going to have to use the average here, so we could get the average number of years spent in the department. All right. When we use what's it called? When we use our averages, we use our sum. I mean, when we are doing these things, we want to use a group clause, right? So as to tell Snowflake or to tell SQL how we want to group our data, right? How are we grouping our data? Since we are looking at the employee number, I mean, we have department name, employee number. These are the most important here, and they are the only dimensions that we're looking at, and the full name. So we are going to have to group by this dimension. We're grouping by department employee number, department number. We have department name and the full name. That's what we are grouping by. So we can go to say we group by employee number, department number. What else? A full name. That's the alias of our contact, right? A full name. What else is there to group by? I think that's all we need to group by. So we don't need this extra comma. So we can run it again and see. Okay. Syntax 5 position. Okay, where's the problem right here? Unexpected. Right. So we use a brace, the closing braces we're not supposed to use. So we can find where that is coming from. Okay. Okay, so we ended, this should be here because we're looking for an average. The closing braces should be here, right? So we can run our query again. Employee number ambiguous. Employee number is ambiguous. All right, just like what we did here, we have an employee number here that is ambiguous, so we can also tell Snowflake or SQL where the field of the employee is actually coming from. So this should actually give us, okay, department number is also ambiguous. Department number, we can be looking at using the department. Here is department number, which is also ambiguous. And we can run department name. We need a department name in our final query. Because when you are doing a group by, you need to actually use the dimensions. Whatever is not an aggregate here, you need to be a group by so that you can tell SQL how you're grouping your output, and that's the reason it's flagging that. All right, so right here we have a final output which is showing the average number of years. You can see someone spent 2 years. This is, like I said, we want this to be as presentable as possible. So we can also use our order by. We can use our order by. We can order by contract length. And order by contract length in descending case. And yeah, we can round this because we have a lot of floating numbers. We can round this. So what round is basically doing is rounding to whatever figure you put after the comma. All right, so it's round whatever number you're rounding. So let's round to 2, or we don't even want to round at all. We are looking at yes, all right, we don't want to round at all. So we can just give a round, and he's just going to round it down or round it up. All right, so this is what we have here. Right now, we actually sorted this in descending order by contract length. So you can see the employees that actually have spent the longest, longest in a department, which is some of those guys right here, and the departments they were or they are actually, right. So this has been interesting. This is the question for the employees. And right now we will be going to the other part, which is the credit recovery, right? The credit recovery, we have about 5 questions, which we are going to be taking one after the other. All right, so I'm going to switch worksheet. Right, so we have a lot more questions here. So like I do all the time, or the mistake I did all the time, the first thing I want to do is actually select the database I'll be working with. Right here okay, right here I also have, I have the script because this database has few tables, right? It has few records of the tables. We are using just 2 tables, right? So I have this, let me know when you can see my screen. Okay, all right, great. Can you see my screen, please? I'm sharing a table. And please, can you confirm you can see my screen? Hi, Anand. I believe you can see the screen. All right, so right here, this is the structure of we need just 2 tables right here. And I'm going to, I run you through the tables we had in the previous, in the previous ones we were treating, which is the employee. We also have different tables here. I'm going to explain what of the fields of those tables actually represent. I'm very curious. Anand, can you hear me, please? Can you hear me, please? Can you confirm you can hear me?
Yeah. Sorry. Yeah.
All right. All right, great. All right, so I'm just going to speak to what each of those tables represents and what each field of those tables actually
represents. And if
also,
Michael, if there is a time crunch, you can show them the code also. Yeah, 1 or 2 you can code it, and then later on, if the time crunch, till 10:30 we are fine. We are good. Next 30 minutes also is fine. You have 30 minutes, right?
Let's work with that.
Okay. Do whatever best you can. Yeah.
All right, so we have the loans table right here. The loans table has all of these columns, right? The first column is the loan ID, right? So the loan ID is the ID of each of the loans. So what this database is actually showing is showing the database of a credit company, a company that gives credit, all right? And when the company gives credit, the company wants to take the credit. So there's a team called the credit collections team, which goes after the loanees. Individuals have collected credit or have collected loans, right? So this is what it's all about. We have the loans and we have the different fields of the table. So the loans table, the loan ID, the individual, each record of this table contains individual loans that has been collected. All right. This is loan 1, which was collected by user 1. Loan 2 was collected by user 2. And you can see the amount that was disbursed and the date that this amount was disbursed. Also, if you come to payment, you see we have the payment ID, we have the loan ID, we have the amount. So payment ID is the ID of loans that has been repaid or part of a loan that has been repaid. So when a loan has been repaid, for instance, loan 1, when a part of it has been repaid, it comes to payment. But if there's a loan that hasn't had any payment, right, you don't find them on payment, right? You don't find them on payment table. And also it has a loan ID, which carries the ID of the loan, all right, and the repayment, the amounts that was repaid, and the dates that were repaid. You also have this type. So this type is showing the type of payment that was made. It could be disbursement, it could be repayment, all right? So this is what this field is showing. So having said that, we can now go back to Snowflakes and, with some questions. So, right, this is the query for creating the queries for creating the tables. We are creating a database, which is a credit recovery database, which you can see on the side here. You can see on the side here the credit recovery. So once you run this, it creates the database. And I already created this, but I just want you to see this. So this is the creation of tables. You create table. This is how you create a table. So you write the create table statement, followed by the name of the you want to create, and followed by all of the columns. Right. These ones are, the constraints or the data types you want the tables to have will follow. So loan ID is an integer. User ID, like you saw before, is an integer. Total amount disbursed is a float because it's an amount. You could have decimal. We have the disbursement date, right? That is for the loans. We have the other one, which is the payment. So the payment is just the same way. It contains all of the fields: integer, loan ID is integer, amount of float, type, string, like the type of payment. Is it disbursement or is it a repayment? All right, so it's a string. And the payment timestamp showing the date and time a loan was repaid or a disbursement was made. And this is the query that actually populates this. All right, so this query, you are inserting into payment, which is the table, followed by the names of columns or the name of the fields you want to insert them to. Then you follow that by values. So values is telling you, all right, this are different values I want to be entered inside this table. This is what that does. All right. So now we can go into answering, some of the questions we have here. So we're going to start from the easiest to the complex questions. All right. So the first question says, what does that say? It said, what is the average time between disbursements? Minimize this. My screen shows very well. All right. What is the average time between disbursement and the first repayment for each customer? And who has the longest first repayment delay? All right. So what this is saying is your stakeholder or whoever that needed to see this is interested in the average time between when a loan is disbursed and the first repayment that a loan is made. And they want to see which of the creditors has the longest first repayment delay. All right. So your repayment delay, of course, is the difference between when you got the loan and when you repay the loan. All right. So some of the fees you'll be needing in this. In our final step should be the loan ID, which actually identifies the loan, the user ID, all right, identifies the user and the loan, and the date difference, which is the difference between the disbursement date and the first repayment date. So we can start with the first thing we want to see is the first repayment date. All right. So CTE, we can first start with CTE block, look at the first repayment date. We can call that first repayment. Okay. First repayment. Why do I type like this? First repayment. Okay. Can just leave that so it's not too long as. All right. So we can with this and then start our select statement. All right. So our first we're selecting, what are we selecting? We're selecting loan ID because we're looking at first repayment. And for our first repayment, we need a loan ID because the loan ID actually identifies of the payment or each of the loans that are collected. You can also look at user ID. User ID, because of course the user has to take the loan. and we look at the disbursement. Okay, we're looking at the disbursement. Then we are looking at the payments timestamp, because we are looking at the first payments, right? We are looking at the first payment, and the repayment is the repayment date, right? Like I mentioned all the time, the repayment field, which is the repayment timestamp, I think. So the repayment timestamp actually identifies time when a repayment is done. All right, but since we are looking at first repayment, that means you're looking at the minimum of repayment. We're looking at the first repayment. The first repayment, that's the minimum of repayment. And we can call that, we can guess that first repayment date. Basically, that is what the CTE is doing for us to recognize the first repayment date. We can as well run that before we proceed to running the other queries. All right, so loan ID, invalid identifier loan ID. All right, where's that coming from? Loan ID, let's be sure that we actually run our credit recovery. So like I mentioned, we should use our credit recovery before you start working. Use database credit, which was one of the problems we made the other time, credit recovery, for you to actually understand that we are working from a particular database. All right, you can try to rerun this again and see. Always remember loan ID. Select loan ID, user ID. Where's wrong? Okay, we can fall back to that. Let's so we don't waste a lot of time. We can see where that is coming from. All right. Since this has been written, we now know we have our first repayment here, right here. We have our first repayment date, which is the minimum of repayment timestamp. Now we can start writing our final query. All right. So our final query, we need what do we need to select? We need to select a loan ID. Oh my bad. Okay, I know where that came from. I know where that came from. All right. So we've actually not finished writing our query. So that should come from the loan table. All right, the loan table. I was wondering what's happening from the loan table. All right, so things all these are not coming from the loan table. Remember, the disbursement date is coming. Sorry, repayment timestamp is coming from the payments table. All right, so we are also going to need to join a payments table. Right here, we are not using an inner join, we're using a left join. Why am I saying that? We're using a left join because the loan table contains some loan IDs that are not on the repayment table. And right now, we're actually looking at loans holistically. We're not trying to sideline loans that have not been paid. So because of this, you want all the records from the loan table join with only matching records from the payments table. Right? So we can do the payment E. All right. Okay, let's alias this L and say on. What is the linking field? The linking field should be the loan ID. Loan ID equals to P dot loan ID. Right, great. And since we are using an aggregate, remember we also need to use a group by. The group by is saying, oh, you're using an aggregate. How do you want me to group your aggregate? All right. So we are grouping by all of our dimensions, right? All of our fields. So we are grouping by the loan ID. We're grouping by the loan ID. We are grouping by the user ID. What else do we have there? We're grouping by also by disbursement date. Okay. Disbursement. Okay. Right. Okay, so now we could actually run into a problem right here because the user ID, sorry, the loan ID also appears on the payment. If you run this, is going to tell us some of our fields actually are ambiguous. So for this, we are going to have to recognize each of our fields by what's it called? The aliases. So for the loan ID, we can use a L to recognize it. We can just use a L2, even though it's not necessary for user ID. User ID only exists on the loan table. And what else? Disbursement date is also on the loan table. What else? Okay, we are grouping by this. We're grouping by this, and we're grouping by this. Right. So I think we should be good. Now, if you try to run this, the CTE says object loan should be loans. All right. That's the name of the table, loans. I mean, these are common things to just run into. That's the reason I actually love Snowflake for the ItaliSense. Repayment timestamp. Okay, where's the problem here? Repayment error invalid. Repayment timestamp. All right, we might actually have to look at select all from payment. So the real name of the table, so we don't make mistakes. Payment. Okay, we credit recovery. We can look at the table. Payment is payment timestamp. Cause this should be right. It's payment timestamp, not repayment timestamp. My bad. So it's payment timestamp, not repayment timestamp, and this should be okay. I think we're good. Okay, we can try to run that again. All right, so right here we can see this is our inner query. We can see the loan ID, user ID, the disbursement date, and we can see only of those 2 loans actually have a first repayment date. All right, which means that only 2 of these loans actually has a repayment. The 2 other loans do not have repayment. All right, we can continue with our query to finish up our query. We already have that information firsthand. All right, so we can proceed to say we are selecting loan ID, we are selecting user ID, see our final query. We're selecting user ID. And we're looking at the, we're trying to look at the longest first repayment, right? At the difference between the 2 dates, between disbursement and repayment. So since we're looking at this, we're using the date first, and then the disbursement date, date, then followed by the first date, the first repayment. That is what we named it. We can just copy it here. Don't make mistakes. All right, I keep making mistakes with, bringing these things out. Okay. And then we can name this as first repayment, or this to first repayment, or this to first repayment, this to first repayment, or this to first payment, or whatever. And then we can go on to write where we are selecting from, right? In code to make it easier to read, in code to make it easier to read. And then we can go to, write from, where are we getting this from? We are taking this from our first CTE, all right? Using our first CTE later on here, all right? So we can put it right here. And then we have this. It's a loan ID. Hey, this is loan, not making the same mistakes. So we have loan ID, and then we can fetch this. All right, so we have the two loan ID user ID combinations actually they delayed by 29 days, and they are the longest repayment, which you can actually see right here, while the 2 other ones haven't actually made any payment. All right, we're able to answer that question, and that looks quite easy to answer. Now we're going to the second question. The second question is calculate the total loan portfolio. All right, so this is more like you're looking at KPIs, right? You're looking at some particular metrics. All right, so this is saying calculate the total loan portfolio delinquency rate. All right, so what you're doing basically is you're calculating the total portfolio. Your loan portfolio is the number of loans that you have out. All right, the number of loans that you've actually given out, that is your loan portfolio. While your delinquency rate is the number of loans that have not been paid divided by the total number of loans that has been collected. That is your delinquency rate. We are starting to write our queries. We need to identify the fields that we need. Right here, we need just 2 fields. We need our total loan portfolio, and we need our delinquency rate. But before we get that, we might actually need to start with a CTE. All right, so we can go on with that. I'll tell you why we need to start with a CTE. So like as usual, the CTE is going to be trying to see the loan repayment status. So we want to give a flag to loan repayment to see a loan that is delinquent or a loan that is not delinquent. So from there, we can actually use that to, for our final query. So we can say loan status. We can say loan status has. Okay, bring this down. Okay, we can start with a select statement. If you're looking at the loan status, always we want to look at the loan ID because the loan ID is a unique identifier of each loan. We want to look at loan ID. We want to look at the total amount that was disbursed, right? We want to look at the total amount disbursed. Total amount disbursed. Yes, and we want to, what else do we want to look at? Then we want to look at only loans that are repaid. All right, we are only interested in loans that are repaid. All right, sorry, loans that are not paid. Right, we're only interested in loans that are not paid because we are paying attention to delinquent loans. Right, so we can say when. Oh, sorry, we're using a case statement. Yes, and we're saying when. Make it more readable. Can say when the sum of the loans, right? When the sum of the loans, all right? So things we also we need the loans are we can now use a case statement and say when is when the type of loan equals to where's my equals to repayment, then you can actually give me amount, right? Else not give me anything, and always remember to use your end. All right, so remember this, we're using a sum here. We are looking at loans that are delinquent, or like loans that are delinquent are zero. They've not had any payment, all right? So we are saying equals zero. When the sum of repayments equals zero, then give me one. Give me one. Else, we can bring the else down here. Else, give me zero. And then we can end the second case statement here. We can end the second case statement here and give it we can give it an alias. We can say delinquent. Delinquent. Yeah, we can call it delinquent. Now, where are we? Where is this coming from? From loan. So since here as well, we are actually dealing with two tables. We're dealing with loans table and we're dealing with amount. Amount is from the repayment table. So we can give this an alias L, and we're using a left join. Remember, we are getting loans that have been paid and loans that have not been paid. So we're using the left join to get everything. And then we are getting it from payment. The alias we give a P, and the join clause is going to be on loan. Yeah. So loan ID, P dot loan ID, P dot loan ID. All right. And remember, we use an aggregate function, so we are still supposed to use a group by function. A group by function, we are grouping by the loan ID, which is the loan ID. I could actually start using my alias here because I use a join. Loan ID. The total disbursement, total amount disbursed, right? Total amount disbursed and what? I think the only fields we need. All right, so our first city is complete. If there's anything we need to add, we can always come back. All right, so our first city is complete. And then we can now our final query, since we need just two metrics. We need the total loan portfolio and we need delinquency rate. All right, so how do we go about that? We can do our select and we can look at the total loan disbursed. Sorry, our total portfolio is going to be sum of total loan disbursed. We can do a sum of total loan disbursed. Total loan disbursed. Okay, we can do a sum of total loan disbursed. We can call that as a portfolio or as a total part value. All right. So the other thing we need again is we need our delinquency rate. Like I mentioned, our delinquency rate is the sum of loans that are delinquent divided by the total loans that have actually been taken. That gives us our delinquency rate. So we can, by saying we want to sum our delinquent, right? Remember, we have a flag here to represent loans that are delinquent and loans that are not delinquent. So we can use loans that are delinquent. Yeah, we're summing loans that are delinquent, and we can divide them by the count of all loans. All right, by the count of all loans. here we can, since you're looking at percentage, you might want to just multiply this by 100. This is an alias, call it delinquency rates. All right, now let's see this. Where's this coming from? Okay, let's see. Loan ID, ambiguous column. All right, we also have an ambiguous column here. Like I said, we could always actually label our columns especially when we have points, we should actually attach to fields that are ambiguous, that are called in more than one table. Okay, total loan disbursed. This I think I spelled this wrongly. We can put amount disbursed what it should be. Amount disbursed. So we can run that again. Not total amount disbursed. What's happening? Okay. Yeah, that should be total amount disbursed.
Check that column. Check that column name. No, view definition. Go back to the table and then check the DDL command for that. Check the definition,
Okay.
how total amount is disbursed. Maybe some letter is missed. Because it's not able to identify it.
Yeah, that's I'll do that. Loans.
From which table you're getting? You're getting from loans. Just see.
Yeah, so it's total amount disbursed. That should be correct.
Okay.
I must be getting something wrong somewhere. Amount disbursed. Okay, so we can try to run that again and see. So the problem always comes from identifying the different fields. Line 73.
But where is the column? You are using aggregate function, but where is the column? Before that, you need to have some column, right? This aggregation total amount disbursed, you are putting on what column? Before that, there's no column, I see.
Oh my God.
Michael.
Yeah.
You missed the
I
column.
get that now.
Any aggregate function which you apply, there has to be.
Yeah. That is, we're getting that from our loan status. Yeah. I mean, that is what happens when you're in a hurry. Because
no, that's what happen when you code live. That's the reason I'm Anand, everything we code live. This is the real scenario.
Yes, right.
And it's not with you, it's with everyone else in the world. With me, with you, with anyone. See, anyone can record the video and anyone can post it. That's just a very cakewalk. But when you code live in front of audience, then the reality comes into picture.
Yeah, that's right. So right here, I mean, we have the two metrics you're interested in. We have the total portfolio value, which is 22,000, and we have the delinquency rate, which is 50%. I mean, 50.000, we can actually decide to, round this. We can decide to, round this here.
Just put comma, 2 decimal place, yeah.
Yeah. Decide to round this to 2, and then run it again, and then round.
D is missed.
Yeah. All right. We have our figures. We have a total portfolio value and delinquency rate. And right here is actually, we are getting to the most important part of this particular thing. So I might have to step on two questions below. All right. So question 4. I'm going to quickly open this so you could see question 4. All right. So question 4 is saying, due to limited bandwidth, the collection recovery team can only call 1,000 users. So here we are looking at priority, all right? The collection recovery team are trying to prioritize because they have, low bandwidth, limited bandwidth. So they are trying to prioritize the loanees they send message to or they follow up with. All right. So now, to limited bandwidth, the collection recovery team can only call 1,000 users a day. So to help the team generate a priority list, for the current date, all right, to generate a priority for the current date based on the following criteria. The first one is to pick only the user ID and loan ID combination where latest repayment date is more than 30 days. And the second one is total outstanding balance is more than 70% of the amount that was disbursed, or total outstanding balance is more than or equals to 10,000. And we're going to rank by user in descending order of total outstanding balance. Well, this is interesting. So this is what the table is going to look like. We're going to have a user ID, a loan ID, how long for the current date did they make the last payment, the total amount disbursed, the total amount that is left, and the rank. The total outstanding amount and the rank. All right. With that being said, let's get started. All right. So I'm going to go back to Snowflakes, and then we start writing our code. All right, so the first thing we want to know, we already know things we need. We need the user ID, the loan ID, the payments, the last time the payment was made, the total amount that was disbursed, and the total outstanding amount. So we need to actually break this down in bits. All right, the first thing we want to know is we want to know the payment summary. All right, we want to have a payment summary that actually give us an idea of what am I doing. Okay, so we want to see a payment summary that actually gives us an idea of how the loan were actually collected. So we're going to use the first CTE. Like I said, before you write your queries, you want to structure, you want to have an idea of what your output is going to look like, right? Okay, so we can start here. Start with our select statement. We are selecting always our loan ID because the unique identifier of the loan ID. The loan ID. And now look at the repayments. We want to select some of all the repayments by loan ID because we are interested in the payments. I mean, we want to see the payment that has been made by loan IDs. All right, so we can use a sum. Since our type table contains both payment and disbursement, we are interested in only payment, so we can use our case statement and say case when type equals payment. Right, when the type equals to payment, then you know what? Just give us the amount. Just give us the amount. Else, we don't want anything. Just give us 0. Right, and always remember end with an end. We can name this payment. Repayment. All right, comma. We can go to what else do we need? We also need the days since the last payment was made. Remember, that's one of the things we are prioritizing on. All right, so we can use a date if, and right here we're looking at day. The last payment was made, right? So we can look at the date of the last payment, which is the max payment date, max payment date. So we can look at, we can say max payment date. Look at the max payment. Is it payment date or payment timestamp? Oh, I keep making this mistake. It's payment timestamp. All right. From current date. All right. Current. This is a timestamp. We're using a timestamp. All right. From the current timestamp. All right. So when you're doing your timestamp should be, I mean, when you're removing the timestamp, subtracting the days between one date, you should actually be careful of what kind of it is. All right, these are timestamp. So the current should also be a timestamp. All right, so we can call this last. We can call this last repayment or last end days. Last end days. I'm not very good at naming, but now let's go. So we're getting this from. We're selecting this from. We're selecting this from payment. All right, we select this from our payment, okay, and then we can group by payment, and then we can group by the only dimension we have is loan ID. Okay. Right, so with that being done, we can go on to our other queries. There should be a comma here because we actually have another CTE to write. Now we have the payment summary, which actually shows the repayments per loan ID and shows the last end date since the payment has been made. So the other one, the other CTE we need is actually for the loan details. All right, so we can call this loan details. And loan details, we are going to be looking at, loans, the total outstanding amount, right? Outstanding amount of the loan. So we can use it. We can start with our select. What are we selecting? We are selecting our loan ID. We are selecting our user ID. Right? We are looking at the total amount that was disbursed. Total amount disbursed. we are looking at the total outstanding amount. The total outstanding amount should be the difference between the total that was disbursed and whatever is repaid, right? So we can say total amount disbursed, which we have here. We can say the total amount disbursed, which we have here, minus repayment. Minus the repayment, and then we can say this is total outstanding. But then when I'm doing things like the repayment, I mean, there are loan IDs that actually don't have any repayment. What if they come out as nulls? You cannot carry out arithmetic on null. So I love to use the qualis. So I mean, when it is null, you can just give 0, which means that the loan was actually not paid, right? It means nothing was paid for the loan, right? Where are we selecting from? We are selecting from, okay, we're selecting from payment. And we can group by what? We can group by all of these dimensions. Okay, qualis. I think we still need some fees that we actually need here. We don't have a disbursement here, so we can still, you know, bring a disbursement date, a comma here, bring in a disbursement date. Okay. What else do we need here? We need this week we actually declare here a last end, which is the last thing was made. And so we can bring this here. All right. I think the fields we need are actually selected. Okay. From loans mentioned, we have other fields here, not from loans. So we are going to do left hand, begin the payment. This is P. Sorry, this is L. And then down here is you can also rename all of our columns. This is L. This is the user ID. We don't need that, but we can still, you know, make it consistent. The loan disbursement amount is still a L. Loan disbursement is still a L. And this is a P. The repayment is a P. All right. No, sorry. We don't need that because repayment is only on one. Where else do we? Disbursement date is also a L. And the last end date is a P. Okay. And then we can go on. We can on loan ID, loan underscore ID. Now we're trying to declare our join conditions to p.loan underscore ID. All right, so we okay, a little error here. Before running that, I can actually see there's an error here because we are left joining on payment summary. It should be payment. We are actually trying to work with the CT here. We can actually bring our CT into this here. Okay, and then we can write our final query. Write our final query. Okay, so we can write a final select query. What are we selecting? We need the user ID. Most of the things we need in the final query has already, you know, inside the CTs we declared. We need the user ID, we need the loan, we need the loan ID, we need the last days before, which is the last end days. We need the last end days. I keep making the same mistake. We need the total amount that was disbursed. Total amount disbursed, which is we need the total amount disbursed. What else do we need? We need the outstanding amount. The total outstanding amount which we declared. The total which we declared here. We can also bring it here. And then remember, I want to do a rank that actually ranks, you know, the outstanding amounts. Right. So we can use a Windows function which is rank. Say what are we ranking over? want to partition by what, right? So here we don't really need a partition. We just want to rank over all the fields. So we don't need to use the partition. So we can just order by outstanding. We are ordering by the total outstanding. All right, we are order by total outstanding. We can give this rank. Right. And where are we selecting from? We are selecting from loan detail. Copy and bring it here from loan details. And then we still have some where clauses, some things we're featuring on where outstanding balance is more than or equal to 70%. And then when last repayment date is greater than 70. So we can also bring those in and use our where. It says where last 10 days greater than or equal to 30, greater than or equal to 30, right? Or the total outstanding amount which we actually declared here, or the outstanding amount is equal to 1,000. And there's one extra or where total outstanding amount, sorry there, my dog, where the total outstanding amount is greater than or equal to 70%, right? We can multiply this by outstanding amount. Okay, where this is equal to 70% of the outstanding amount. Now let's see. Let's run that. This is a long one. Let's see that. Okay, it says line 6, A. Where's that? Okay. Okay, there's a mistake here. We can try to run that again. Loan ID. Okay, this is a loan ID, not loan. Okay, all right. We got our query, our final query here. We can see, I mean, there's been a priority list as the question said we should, and it has ranked based on priority. All right. First look at those that have not made any payment. Look at the total amount disbursed. From what the total amount disbursed, total outstanding amount, and then the rank, all right, which we actually have out here. It has ranked based on how should actually be treated. We could actually use a rank here because it asks us to use a rank as well, right? It asks us to use a rank, which we did here. Okay, last index is greater than 30. Okay, yeah, we did everything. And yeah, this is a final query, which is actually showing the user ID and the loan ID combination, the last day's payment, the total amount disbursed, and the total outstanding payment. All right. All right, so we can go to the final question here. This is the 5th question. All right, so the 5th question is also a very long one. So the last 2 are the most complex of all of them. The 5th question is actually saying, we will go back to a question right
Fifth
here.
one, Michael, you can explain them and then you can show them the code. No need to write. Already you have written so much. Show them the approach. That's fine, I think. This is the last question. How many questions we have?
It's the last one. The 5th one is the last one.
Let's do it. Okay, fine.
All right. So the 5th question, the 5th one is, look at this, what we have right here. We have the 2 tables. You're familiar with the 2 tables, right? So now we want to see a query that creates the table. We have the outstanding balance on each day from the disbursement date to the last repayment date of the loan. I'm going to explain this. I'm going to make this very easy to actually comprehend for each user loan combination. So for this table, we are trying to see it. So for instance, user ID has a loan 1. User ID 1, a loan of 12, right? On this day, a loan of 20,000 on this day, all right? If he pays 15,000 on the same day, his outstanding amount is 5,000, right? And that 5,000 is going to be there until the next repayment. So right here, we're going to have a situation where we're having a loop, all right? If I make a payment today, or if I take a loan today and I don't make any repayment until 5 days from now,
I'm going to go through all of the days, and I'm going to have a record that shows my outstanding amounts for each of the days. So if I've not made any payments, the $5,000 loan I corrected is still $5,000. It is not reducing until I make a payment. Now the payment is my record now is going to show my outstanding amount, my outstanding balance, and the last time I made the balance. So that is what's happening here. All right. So here we have the date disbursement was made, the user ID, loan ID, total disbursements that was made. You can see this is consistent down the column. The total outstanding amounts, which actually reduces down the column depending on when payments are made, and the latest repayment. All right. So the latest repayment is going to keep going. I made a repayment today and I don't make tomorrow. My latest repayment is going to be today. So yeah, let's go back and write some code. All right. So the fifth, what do we need in the final query? We need the dates, like I just showed. We need the user ID, the loan ID, the total amount that is disbursed, the total outstanding amounts, right? The total amount disbursed, outstanding amount, and the latest repayment date. Now we can start writing. We're also going to use some CTEs, which we're going to leverage on later on. So we're going to start with that with. So in order to do this, in order to have a date that keeps recurring, right? Recurring, we use something in SQL called the recursive CTE. All right. If you've used workbenches before, the syntax is with recursive, and then you name the name of your recursive CTE, but it's quite different in Snowflakes. In Snowflakes, you make use of a function known as the SEQ, which is going to create a sequence of numbers which you can use. And I'm going to show you how that works. We're going to call this series, right? Because we want to have set of days from the first day till the 60th day, which is the last day of prepayment. All right. So date series as, you can say with series has, let me move this up. Sorry. Okay, great. So we can say with series has. Now we can come here and say we want to select, what are we selecting? Want to select, now we want to select our first column. This is just one column we need for this, which is the sequence, CQ4, and then we can have this. All right, so this is it. We can name this N. From, it also works with another function that is called the row count function. All right, this is how it is written. A generator. All right, it generates a row count. All right, thanks. It generates a row count. We can have a row count, which is equal to. So we want to generate 60 days from the first day of disbursement. So we're going to say equals to 60. All right. The sequence always starts from 1. So we can run this and see the sequence always starts from 1. We're going to generate a sequence of number from 0 to 1, row count. What's happening here? Generator, row counts. Okay. So this is how I actually work with the generator. It is not an equal. I missed that. So let's run this. I'm expecting just one single field that has numbers from 0 to 60. All right, great. This is what we are going to use later on in our query to actually look through each of the days, subsequent days from the days of repayment, and show, what has happened in each of those days. All right, so we can now, write our other queries. So we are going now to the next CT. So this one is to get loan details. All right. The second one is to get the loan details and the latest repayment date, which is also very important in our query. So we're going to call this CTE. We're going to call it loan details. Right. As okay. I don't know when this came into this. All right. With loan details as, now we can start our select for this particular one. We will need our user ID. We are going to need our loan ID because we're looking at user ID, loan ID combinations. We're looking at our disbursement date. We're looking at the total amount that was disbursed. total amount that was disbursed. Okay. And then what else are we looking at? We're looking at the max payment date, which is the date the last payment was made, all right? Because we are supposed to have the last date, the date the last payment was made, and then the date keeps going on till the 60th day, which is supposed to end the loan tenure. All right. So we're going to call this max payment. It should be timestamp. I'm not making that mistake again. So we can do this alias of last payment. All right, I think we are good with it. So we can say from, where are we selecting from? From loan. Loan. Since many of we can give our loans to, let me quickly give my aliases. Loan. Disbursement date is also loan. What else? What else? Loan disbursed. Loan disbursed is also loan. All right. Since payment timestamp belongs to only payments, we probably do not need that. Doing a left join. The left joining on payment. Payment P. Left joining on payment P on L loan ID. Of course, P the loan ID. All right. And then another condition we want to put here is we want to look at repayment. Right. We only want the rows. We only want the rows whose type only equals repayment. So we can also add that in our in our join clause where type equals payment. Right. Okay. Type equals payment. Right. Since we are using a max, which is an aggregate function, remember we want to use group by. So we are grouping by all of the fields. All right. So L, I think we can just copy all the fields. Right. Efficient. All right. So we are grouping by all of those fields, and then yeah, that would be CTE. So yeah, we have another CTE, so we can proceed. The next CTE we are going to write is going to use to calculate the daily balance. Now we already have our loan details. We have our loan details. Now we want to look at the daily balance of every day, after the disbursement. So we're going to call this daily balance as. Okay. Again, select what are we selecting here? Our daily balance. We need the field from here, but this time we actually need it to pair with the field from the series. We want the days to actually continue to exist until the last day of repayment. All right, so this is where we are going to use that. So we're going to have a loan ID. And we're selecting from the table above actually, from the three tables above for the cities. All right, have the let's start from the user ID. User ID. And we will use the loan ID. We use we are also looking at the days from the first day, and we want to keep looping through the other days, right? Through this number. So we are going to use 3 that says we're going to use a add. What's happening? We're going to use a add. Okay, function, here we go. Not there, not there. So we're going to use add. And out of the add, you're adding 2 days together. You're bringing 2 days together, right? So you're trying to add days to the disbursement date. So just like the date, it starts with the type of date, and then we have this right here, and we have the series here. We are going to bring in the end from the series, and then we are going to add it to our disbursement dates. Our disbursement date. All right, so usually that is what we're doing here, right? So I think here date. Okay, we are going to also we need our total amount that was disbursed. Total amount disbursed. Okay, also need that information. And where are we selecting from? We are selecting from. Okay, so this is where we are going to see some a little bit complex stuff. We are selecting from loan details here. Loan details, we can call it. We are now joining. We're joining with this. But now, how join works? We join two tables that have. When you want to use your normal type of join, your inner join, your left join, your right join, right? You want to join two tables that have common fields. But since this table does not have a common field, this is just a single table. Our first city here is just a single field of a table. Right? So how are we going to do that? We're going to use a cross join. The cross join is a Cartesian join. It's joining every record of the table, all the records of the table. So since we have only one disbursement, it's going to keep going, keep counting, keep adding. So that's why we had date add. So it's going to do the first day plus this, second day plus this, the third day plus this, and keeps going. So we're using a cross join. We're joining date series. In series and call it DS. Right. So we don't need to, since it's a cross join, we don't need actually a cross, what's it called? A cross condition. All right. So we can see to use our where statement, where date add. What we are doing here is we're looking at where the disbursement date is less than or equal to last payment date. All right. So add. You might want to have to watch this video again because it's a bit of a complex one. We had add where here. Copy this. All right. Where you are adding up together, all right? Less than or equal to the last payment date, or where the date add, same date add, right? This time is less than or equal to it's less than or equal to 60 days after the disbursement day. Okay, so since the payment payment tenure ends after 60 days, so we're doing another date add that says ends, this is day 60 days after the repayment. After the disbursement day, pardon me. After the disbursement. All right, we're almost there. Okay, I think that is correct. All right. All right, so this is okay. Now we can now proceed. Okay, great. We can now calculate the balance and repayment. Now that we have this, last CTE is going to be balance and repayment. All right. What this is doing is calculating outstanding balance and latest repayment every day. All right. The first three CTEs we are looking. The first one is to generate a list of numbers which you can use an addition to our days. The second one is getting the loan details, while the third one is actually looking at bringing them together, and we are looking at the loan details every day. Now the last one is we are looking at balance. We're going to call this balance. Let me see, balance and repayment. We're going to call this balance and repayment as we're going to do this and say a balance repayment. We're going to select, okay, we're selecting dates. All right, so we are selecting a date from our daily balance. We have a date from our daily balance. Date. Okay, we are selecting user ID from our daily balance. User ID. So basically, everything we need is from here. This is the major CTE right now, which we are actually, referencing. We need a loan ID. We need a loan ID. We will need total amount of board. Total amount of board. Okay. What else do we need? We need to see the difference between the total amount disbursed and the outstanding balance, which is going to, the total amount disbursed and the total amount paid, which is going to give us the outstanding balance. We're going to do total amount disbursed We're going to do total amount disbursed. Then we're going to coalesce like I did before. We're going to coalesce sum of amounts. And when it is null, it gives 0. Okay. Okay. And then you can name this as outstanding balance. Total outstanding balance. Great. All right. So we are almost there. What else do we need? We need to actually also have the latest repayment date, which is the max repayment date, right? We also need that. So we're going to have a max repayment date, payment timestamp. All right. So all this we're going to need in the final query. Last repayment. Okay. Okay. As the last repayment date. And then where are we getting this from? We're getting this from a daily balance. Daily balance, which we have up here. Don't make any mistakes. I can just copy that here. From our daily balance, which is DB, right? Because you still need to, join payment. All right. You need to join payment P. And what clause are we doing? We are joining on daily balance dot loan ID. Of course, loan ID. Loan ID. Yeah. And we also have other join clauses, which is we're also looking at where payment timestamp is less than the current date. So we're okay. Where the payment timestamp here. Timestamp, right? It's less than or equal to the date that we have, which is a d.date. Okay, and the final one is and type for payments. Okay. Since we have an aggregate, we can now use our group. We can copy all of this. What am I doing? We can copy all of this. This. And use our group. And we can also use the alias here as our group. Okay, great. Now we can write our final query. All right, so our final query is now bringing everything together to make to bring out the final output. So here we can now have dates, the dates. We have the user ID that we saw in the table. We have a loan ID. We have the total amount disbursed. We have what else do we have here? We want to also have the total outstanding amount. The total outstanding amount is going to be we calculated here. Total outstanding amount. Where do we have total outstanding balance? Okay. We have the total outstanding balance, but just in case there's no total outstanding balance, we use our coalesce. Just in case there's no total outstanding balance, we just going to return the total amount disbursed. Right? So we can name this as outstanding amount. Great. Then what we finally need, we need the last payment date, right? So finally we can look at the last payment dates. We use that here somewhere. Latest payment date, right? Okay. is our latest payment date. And we can call this as latest repayment. And from where? And use it from balance and repayment. Use it from balance and repayment. And then we all ask to order by word. We are ordering by the user ID, ordering by the loan ID, and we're ordering by the this should run. Let's see. Okay, syntax error. Where is that? Let's box real quick. We have a long code here. One for okay. Loans. This is gonna be a long the borg. Okay, the div. This looks all good. The date from balance and payment. Okay, this is good. Where is that coming from? Written a lot of written a lot of lines already. Line 134. Okay. Can it be here? Repeated date. Data 30. I'm gonna label this. Let's see that. We should have the same. Where is that coming from? Anand, are you with me? Can you
Yes, I am with you. I'm with you. I'm seeing.
yeah, so I'm trying to see where that came from.
What happened? Unexpected line 134. Bracket is missing. 130. Go up, go up, go up.
No, we don't need the ones up. I mean,
Is there that bracket? 134 you need to comment. 134. I can see the bracket. Comment that. Comment that. Comment that. Just comment. Yeah.
Let's see.
Just turn on the highlighter, no? Michael, turn on the highlighter in the settings. That's good in Snowflake. Yeah, turn on. Yeah. So in that way, you can see where exactly. Now you see what line of code is getting executed. Okay, come down. Data series, check the spelling.
Dates, where?
Up, up, up. The first CT, data series 148.
Oh, date series, that is correct. That's date series. What about where I did the join? So lots of debugging to do because I wrote a lot of queries, and that's why I love to actually run while I write them. Date series. Then where I join the date series. I'm still complaining about an opening bracket. Loan details. Be selecting this. Okay, let me see this. Payment. Where is that? Where is that? Okay. Unexpected payment.
Unexpected payment. Where is that? Line 185. Check the line number. 185.
185. Yeah, that's where I'm on.
Unexpected payments. Which payment does it talks about?
I'm gonna find that.
Type Control F and paste that payments with S. Do Control F. Right. PAYMENTS.
This is the payment here.
Okay.
185.
What is
Oh,
left?
what
Left
is-
join. Join, you missed it.
Oh yeah. Oh my God.
That's the beauty of live coding, Michael.
Yeah.
This is how we work.
Okay.
Unexpected
now-
date. Now check the date.
Okay.
Unexpected date. Line
Unexpected date.
187.
187.
That date it is not able to be. The last date. db.date. The last word which you have written.
Okay.
Yeah,
Okay.
see that from where it is coming.
We have here db.date. Let me remove db.c.
No, db.date you have tried, not from date. db from your taking from db. Daily balance, the CT you have given us db.
Yeah. From our city, we have a db. From the join, we have a db.
db.date. So write db.date then.
db.date. I can maybe use it here as well. I think it's seeing that as because it's
Maybe
the function failing to recognize that. I believe.
Yeah, no,
Still the same thing.
Still the same thing.
Let's see. db.date says syntax on 187. Left join payments. Okay, you know what? Let me just use this here and use this here. Then the same.
Check the code which you have published in the GitHub. Maybe see something you might be missing. Check the original code.
Okay.
Yeah.
Okay.
Check
Okay.
once.
Okay. A minute.
Just have a look.
Okay.
So those who are watching us live, this is how the real scenario is. This is the real interview experience.
It's a very long code.
Last time I was interviewing for the data architect role, I was doing a syntax error. Imagine it happens. It happens. This is not a traditional live class, no, where a normal class where you record the video and upload it. So these backend thing people are not aware how things happen when they type code. Things happen when you code live. Now see the answer. Maybe we are missing something.
Right. So
check what we have missed.
Right here.
db.user ID you have given. Everything from db. Copy this. Copy the entire thing. Copy the entire thing. Better to copy the entire thing. Then explain it to them.
Okay. I'm very curious too. Now I just want to put that on a different line. Okay. Let's run this. Let's see. Where is this coming from? The balance.
Check the daily balance. Maybe somewhere.
This is the daily balance here, right here. Oh, I didn't complete. It's not complete, so I copied. I was try copying from the balance. I made a lot of C. Okay. Yeah, this is a very long one. Okay, let's try that again.
Daily balance line 206.
Yeah, I think it works now. Yeah, so we must have, used some kind of somehow while typing some kind of typo error. Yeah, basically this is what we have. So we have the first date from the first date of disbursement. This is the user ID. This is the loan that was disbursed, 5,000. There was no payment on the first, and then no payment was made until, if it comes down, first payment of 1,000 was made on the 22nd, on the 1st of October 2022. Then he carried that down till the next payment was made. So apparently no payment was made again until the loan tenure actually elapsed. You can see this is user ID 1, loan ID 1. Now, user ID 1, loan ID 2, this is the same user taking another loan. He took a loan of 1,000, then no payment was made till the loan elapsed. And then it went to user ID 2, and like that, go. Right. So basically, if I should quickly run through this code, what we're doing here is, we've used the series, which actually gives us a count of, let me remove the highlighter. We're using a series, which actually gives us a count of, it gives us a field that has count from 0 to 60, 0 to 59, right? And then from there, we wrote a code that got us loan details and the latest payment dates. All right, so I made this very easy on the GitHub so everyone can actually learn why they go about it. All right, so this gives us the loan details and the repayment date of the loans. All right, it gives us the loan user ID combination and the repayment date, and then the third one, it generates a daily records. Generates a daily record, which is where you actually combine this loan details with the series, which has a field of 0 to 59, which is 60. All right, that's what you do here. So it increments by 1, your disbursement date increments by 1 till the last day, which is to day 60, which ends your loan tenure. All right, that is what happens in the daily balance. And then to step 4, which we have the balance and repayment, where we have this. Here we were looking at the outstanding balance and latest repayment date, which is what we have here. We have amount disbursed. Here we have our outstanding balance. Looking at the total amount disbursed minus amount which was paid. All right. And we also have our max repayment. All right. Here we have our outstanding balance and max repayment. And the final query now brings everything together to make more sense. So the final query, we have our date, our user ID, the loan, the total amount disbursed, and then we have the difference between, and then we have our outstanding balance. Right here, this is saying there's no outstanding balance, like the individual hasn't made any payments. There's no outstanding amount, just return the amount disbursed as the outstanding amount. That is what we have here. And this is the outstanding balance. Let me put it on the line. And then we finally have the table we're copying from, and then our order by clause, which is great. That is basically, it's a very, very long one. You might actually have to go to my GitHub to actually see this. It's a very interesting one, and a very, very long one. Hi, Anand. I think that is all from my end.
Yes. So this was a very, very good case study, I would say. Michael, thanks for this. This I have done enormously in my last 7 years career. This is how we write the real code, and this is how we face sometimes syntax errors, sometimes we do mistake. That's how we learn. This is all you learn, I learn, and everybody has learned like this only. We can master SQL case study only when we have focused on individual component. What is date add function? What does collist function do? What does joins do? Right? How does order by works? What is where clause? So bits and pieces we have to integrate, and then accordingly, guys, you can do all these case studies. So these are real case studies which Michael has shown it to you. So go through the code. GitHub link already I have given in the chat. In the description of this video. So you can go ahead and have a look. Just execute this. Those who will be watching this video later down the line, you don't have to watch the entire video. Just understand what has been discussed in this entire 2.5 hours case study. I think this was very, very important from me. That's why I onboarded Michael, and I wanted him to explain how he is using and what kind of business case studies he is working or he has worked over a period of last 3-4 years down the line. Right? So thanks, Michael. Michael, you're there? Yeah. Just 1 or 2 minutes more. Immense thanks to you for coming here live here. Now, folks, those who are watching us, let me tell you, Michael soon will be taking all our Tableau courses, which will be kickstarting. We are planning, me and Michael are having discussion. So probably in February 2025, you'll see a full-fledged Tableau course, which Michael will be completely taking care. Right? I think, Michael, it's very, very late for you now. Go chill, have some coffee, enjoy with your family now.
It's rainy there as well. It's rainy
day over there. Okay.
It's just about 7 p.m. right here.
No
so
worries.
It's still not so late.
Okay. Thanks, Michael, for your time. Right?
All right.
Yeah.
Thank you, Anand.
Okay. Yeah. Thank you.
Right.
Yeah. Enjoy. Have a great day. Yeah.
And you too. Yeah.
Yeah. Sure. Yeah. So guys, I'll be sharing my screen quickly before we wrap up. I wanted, yeah, so that was Michael, which you see him. Yeah. So those who wants to be a job guarantee program, go ahead and enroll in this. Still, it is open for you all. You can buy on EMI. You can pay in installment. It will cost you 5,996 if you cannot afford it. Right? Those who wants to go with one shot payment, straight 30,000 rupees is for you all. This entire 3,000 will be waived off and you have to pay 30,000. Either you can go by EMI. So if you go with this 33,000, you can pay by credit card, debit card, all those offers. Just see if any coupon code is there. There's no coupon code because Diwali offer has been subsided now. So go ahead and enroll in this course. You know the full-fledged syllabus is there where I'll be teaching you every Saturday, Sunday, 11 to 1, 3 to 5. And recently we have started with 9 to 11. Also, you have Excel, SQL, Snowflake, Power BI, Tableau, Python, MongoDB, Matillion, Alteryx, R programming. Nowhere in the world where Escape Red, Statistics, Azure, AWS, and GCP, all these things are integrated in this. That's a very, very exhaustive course. Every day you need to devote 2 hours, right? It will go 8 to 10 months down the line. We have started it. So it's an ongoing program which you can enroll anytime during the year, and I'll take it from here. This is customized based on you. Where do you stand? If you're from non-tech background, if you're a technical background, no need to do all the modules. I will be there guiding you all. So this is where your job guarantee come into action. So anyone, those who are graduates, those who are from another background, irrespective of your background, this is the course in the current era which I want you all to enroll. And trust me blindly when I say that, I'll get you placed. That's my headache. Your headache is to just study, 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 nothing else. If you don't get placed, I'm there. Right? So all I'm asking is to go ahead. If you have not enrolled, go ahead and enroll in this course. And do follow Analytics with Anand for all your data analytics related updates. Usually I get busy with my work and all those things, but I'll try to keep up more often Snowflake videos. Still, the playlist is not yet over. There's so many things which I have to explain it to you. So yeah, I'll be coming up with the new videos. Till then, you have any query, feel free to reach out on LinkedIn, Instagram, YouTube. You have my number, you have my phone number, you have my address. So right. So there we go. Good night. Take care. Bye-bye. I'm signing off for now. See you soon. And do subscribe to this channel and let the data do the talking. Bye-bye.